number of observable patterns in and chemical properties of the elements as we come down in group move across the period. For example, if you see the atomic size, generally atomic size in first period or second period or third period, any period if you observe left to right, it will always what happen? Decreases. Okay. Similarly, what happen in any group if you observe, or first A group or second A group, top to bottom, what happen? It will increases. So this is the trend I'm saying. There are many observable patterns like atomic size, isn't it? Their properties are regularly changing, isn't it? This is what actually periodic properties. Definition you need to remember. बाकी का आपका छोड़ देना है. For example, we'll see some physical properties in this one. What are the physical properties here? First one, atomic radius, ionic radius, ionization enthalpy, electron gain enthalpy, and finally what happened? Electronegativity. These are the 5 properties, actually 4 properties only, but atomic radius and ionic radius we complete in same only. So all these are the 5 properties generally we discuss in this periodic properties. 5 periodic properties we are discussing now. Today let me see the atomic radius. Now how to write the definition of atomic radius? If anybody asks you what is the meaning of atomic radius, my voice is audible for you? Is enough? Shall I speak?
Yes, sir, it is audible, sir.
Shall I speak loud? Otherwise enough.
It is okay, sir.
Right, very good. Okay, thank you. The distance between the center of the nucleus and outermost shell of atom, that is called atomic radius. I'm drawing a diagram here. Okay, I'm drawing a small diagram, something like this, isn't it? This is a small diagram. Now this red part you are observing, that is a nucleus, right? The red part you were observing, that is called nucleus. Now where is the outermost electron? If you observe what happened here, it is outermost electron. Here it is outermost electron. This part is the nucleus and this is the outermost nucleus here, isn't it? Now the distance from the center, from here, from this blue, whatever the blue line you are observing now, that you are calling as atomic radius. So the diagram shows what is atomic radius. Very simple. The distance covered from center of nucleus to outermost shell. This blue part you are observing now, this is called what? Atomic radius. Correct or not? Understood, everyone?
Yes, sir.
Yes. Right? Now, is it possible for you to scale this? If I give any scale for you, agar Prathamesh hai na abhi? Prathamesh hai?
Yes, sir.
If I give any scale to you, some scale, and if I give you, if I ask to measure the size of what helium, is it possible for you? Is it possible, beta?
So I didn't understood the question.
If I give any scale for you to measure the size of atomic radius of helium atom, is it possible for you? By using yes or no?
No, sir.
Yes, sir.
It is not. If somebody is saying yes, वो सो रहे हैं, जो बोलते हैं yes वो सो रहे हैं. नहीं, तो possible नहीं, क्योंकि वो are there what very small atoms are generally very small. You can't see the atom by the naked eye, isn't it? Even normal microscope also we can't see. Okay, so it's because of small size, generally atom present in angstroms, isn't it? The size of the atom generally shown angstroms or nanometer or picometer. Isn't? These are the sizes or what actually very small size. So measuring directly is very, very difficult. So how to measure this one? By using X-ray diffraction or spectroscopic methods, we can identify the atomic radius. Now, there are 3 types of atomic radius out there. One is called covalent, other is called metallic, and the last one is called Vanderwaals radius. So 3 types: covalent radii, metallic radii, and finally third one is called what? Vanderwaals radii. Correct? Right. Now let me see each and everything. First one, covalent radius. What is covalent radius? So first of all, we'll see the diagram. After that, what happened? Let me see the whatever the definition and the isn't it exam. Now here, how many chlorine atoms are there, beta? In the Cl2 molecule, how many chlorine atoms are there? Tell me first.
Two, sir. Two, sir.
Yeah. Okay. Now when they bond, what happened? They overlap like this because chlorine and chlorine they formed a bond.
Two, sir.
No, they formed like this bond. No, so that bond I'm showing something overlapping like this. One first chlorine, second chlorine. They bond like this. This is a bond actually. After bonding, what happened? Something will be overlapped. This will be overlapped like this part will be overlapping. Okay, this is a chlorine molecule. Simply it is a chlorine molecule. Now, this is the nucleus of the first chlorine. Here, the red part, first chlorine nucleus, and this is the second chlorine nucleus. Now, the distance you have to take. What is the distance between the internucleus distance? What is the internuclear distance between the two chlorine? That I am drawing like this. Okay. This is the internucleus distance. Otherwise, what happened? You can write like this also. How much it is? 198 picometer. The internucleus distance between the two chlorine atoms. Nucleus of first chlorine to nucleus of second chlorine is 198 picometer. Now, what will be the covalent radius? Now we have to take half of this one. Only take what? Half of this one. Now half will be how much here? 99 picometer. Now the covalent radii of chlorine, isn't it? Is nothing but what? 99 picometer. So what is the definition? Now you observe that the half of the distance between the nuclei of two covalently bonded atoms is called of same element in the molecule. See, what are the same elements present in this chlorine molecule? Chlorine are the same elements. Is called what? Covalent radius. Half of the distance between the two nuclei of two covalently bonded atoms. Otherwise, simply half of the internucleus distance between the atoms of a given molecule is nothing but called covalent radius. For example, the internucleus distance of chlorine is 198 picometer, isn't it? The internucleus distance is given how much? 198 picometer. Then it will be 99 pic. For example, the internuclear distance between, just imagine, this is not correct value, just imagine hydrogen is something what happened, 182. For example. Now tell me what is the radius of hydrogen? Anybody?
Sir, 91.
91 picometer. Generally we are writing picometer, so 91 picometer. This is the way of calculating the covalent radius. First radius called covalent radius. Next move to what? Metallic radius. Generally covalent radius will be given whichever the molecules are covalent like what something what happened, chlorine, bromine, like that. Whichever form covalent molecules. Now, for metals like copper, silver, arum, scandium, titanium, there are number of metals are there. No, for such type of metals, isn't it? We calculate radius called metallic radius. Now, if you observe the covalent and metallic radius, the two atoms are near or away from each other in the metallic radius. When you compare with what covalent, these two atoms are away or near?
Away, sir.
Away.
They're away. Little bit what happened, they're away because they are not forming in. Because in the copper crystal, what happened? There are no bonds between there are metallic bonds are there, but they are weak bonds. So there are no overlapping will be there. So don't take any overlapping. Now here also what happened? You see the internucleus distance. This is the internuclear distance. How much it is? 256 picometer. Now take half of the distance here. Half of nothing but what? 120. 56 means 25 plus 128 picometer. Here it will be 128 picometer. So the same thing again, but the difference is what? The diagrams are different, isn't it? So definition is what? Same only. The half of the internuclear distance between the two adjacent atoms of metallic crystal is known as metallic radius. In this case, you have to consider adjacent atoms of metallic crystals in the covalently bonded atoms. In that covalently bonded atoms, here what we are taking? Adjacent atoms. So in this way, we can easily calculate the metallic radius. Next, we'll see the Vanderwaals radius. Generally, when we'll take Vanderwaals radius, especially for zero group elements, isn't it? Which are between the molecule. Here also we can take chlorine we can take, but the way we are taking that is different. You see, in the previous case, we have taken half of the distance between the covalently bonded atom, like this we have taken. But in the Vanderwaals radius, no, between the molecules we'll take it. Within the molecule, if I take, that is covalent radius, right? Within the molecule. Between the molecule, this is a different molecule, this is a different molecule, but of same elements. Now here, half of the distance, how you take it? Let me see the diagram. Now, half of the distance, how you take, you see like this. This is the taking of half of. Now the distance between the molecule also increased. Okay. Generally, we'll take for noble gas, whichever unable to form the covalent bonds, whichever the molecules unable to form covalent bond, we'll take that. Now, between these two, there is no covalent bond actually. Between these two, there is no covalent bond. You can take even helium, neon also, you can take helium atom, helium like this. This is the helium, and this is the helium like this. So, also you have to take half of the distance only. The 3.72, if I take, what happened, you will take 1.86. Anywhere you take half of the distance only. Now, what is the definition? The half of the distance between the nuclei of two adjacent identical atoms belonging to neighboring molecules. See, these are the two, same or not? These two are same or not? Tell me. Same only. And they belong to what? Neighboring molecule. They are not having any relation. They are only neighboring molecule. These two are, this one and this one are neighboring molecules. So they should be taken in the solid state. That is the condition actually. Then they are called Vanderwaals radius. Just remember the definition. If you remember the definition, what happened? The formula will be very simple. Formula will be half you have to do. Whatever they will give distance like distance something. What happened? They will give chlorine and the chlorine they will give like this here. Something about 1.86. You have to calculate the radius of the chlorine. You have to calculate just by dividing with 2, isn't it? So this is about the Vanderwaals radius. Now let me see some questions here. Now anybody? The distance between center of nucleus and outermost shell is called?
Sir, atomic radius.
It is called atomic radius. Just now we discussed this one. Right. Next, we'll move to what? With the reference to the diagram given, the Vanderwaals radius equal to something. Now, what they're asking here, what is the Vanderwaals radius is equal to? Because based on this diagram, you have to say Vanderwaals radius will equal to, they're asking here.
So option A.
Sir, option A. Sir, A option.
See, actually what Vanderwaals distance you have to take from A to, they're asking what? This is actually what? A to what? A dash, isn't it? A to what? A dash, isn't it? Now we have to take half of the distance. Half of distance कितना होगा? Half. So इसमें half क्या होगा? A dash C होगा ऐसा. नहीं तो AC. Either AC or A dash. Both will answer. So answer will be taken as AC or A dash, isn't it? It looks what? Isn't it? When I draw what happened, it is very simple or not? Correct or not? See, this is a distance actually. Distance if they ask what happened? ACA. But radius will be what? Either AC or A dash C or AC will be this, right? Next. The following is the largest radius of them. Now tell me which will be the largest radius generally, which will be maybe raw.
Sir, metallic radius.
Again आपको
Vanderwaals radius.
कहाँ पर आपको ज्यादा डिस्टेंस आ रहा है देखो बेटा, यहाँ पर एक बार मैं दिखाता हूँ, यहाँ पर कहाँ पर आपको ज्यादा डिस्टेंस आ रहा है देखो, पहले ये देखो, फर्स्ट ऑफ ऑल कोवलेंट देखना है आपको, कोवलेंट डिस्टेंस कितना है यहाँ पर देखो यहाँ पर, और नेक्स्ट मेटालिक में देखो डिस्टेंस ज्यादा आ रहे हैं, और फाइनली व्हाट हैपेंड वांडरवाल्स में देखो देखो कितना डिस्टेंस आ रहा है, देखो कहां पर आपको ज्यादा डिस्टेंस आ रहा है बोलो अभी।
सो वांडरवाल,
सो वांडरवाल्स करेक्ट वन है। सो वांडरवाल्स में आपको ज्यादा डिस्टेंस आएगा, तो रेडियस भी कम ज्यादा कितने आएगा, किसमें आएगा ज्यादा डिस्टेंस? अगर इफ यू टेक रेडियस विथ रिस्पेक्ट टू वांडरवाल्स रेडियस, द रेडियस डेफिनेटली व्हाट हैपन more. So which of the following is the largest radius? Vanderwaals radius is largest, isn't it? Next, one more thing also I will explain here. When they are away from each other, their force of attractions will be B. Now in this case what happened? Covalent radii, isn't it? Covalent radii, RC means covalent radii, is always lesser than which one? Metallic radii. M for what? Metallic. And which one is what? Vanderwaals radii. बट फोर्स ऑफ अट्रैक्शन ज्यादा किसमें हो जाएगा? वांडरवाल्स में और कोवलेंट में। अट्रैक्शंस कम ज्यादा किसमें हो जाएगा? अगर
Sir, covalent.
covalent, when the length is shorter length, attractions will be strong. So in that case, what happened? In this case, more attractive forces will be there. In this case, we are going to have more attractive forces. In this, we are going to have less attractive forces. Because of what? Actually, the distance. Shorter distance, what happened? More attractive forces. ये भी पूछ सकते हैं एग्जाम में, तो थोड़ा ये आपको नोटबुक में लिखना है. जो रेडियस लिखना है आपको नोटबुक में, और फोर्स ऑफ अट्रैक्शंस भी लिखना है ना. जो डेट, आज का डेट डालकर आपको लिखना है. मैं नेक्स्ट मंथ से कंपलसरी शुरू हो जाएगा क्लास. आपको दिवाली के बाद हो जाएगा आपका क्लासेस बेस शुरू हो जाएगा. नहीं तो एटलीस्ट 1 तारीख से हो जाएगा क्लास आपका. तो मैं कंपलसरी सभी नोटबुक देखता हूं. नेक्स्ट, the trends in atomic radii of elements can be explained in terms of nuclear charge and energy level. This we'll see in the next one. Now, if you observe the atomic radii across the period, left to right, isn't it? What happens? Nuclear charge increases or decreases? Tell me better. In any period, nuclear charge always what happens? Increases. For example, we will take some example. I will take what happened. An example I will take actually. You take this one. Now, यहाँ पर न्यूक्लियस का जो चार्ज कितना है बेटा? सेकेंड पीरियड में न्यूक्लियर चार्ज कितना है? न्यूक्लियर चार्ज आर यू देयर? स्लीपिंग?
Yes, sir.
स्लीपिंग सभी ने. 61 स्टूडेंट्स हैं आपके क्लास में. जो रिप्लाई आता है मेरे को 10 members, mostly what 10 members, remaining what happen? They sleep, they do anything in the home like that, isn't it? Once will school open? No. So I know who are replying to my questions. I know names also. I know that one. Who will does not reply and they are getting 19 marks. I know that one. Who got 19 marks? With, they don't know anything. They got 19 marks. I know that people also. So that is the reasons you have to respond in the class. If you don't respond, what happened? You will be definitely what happened? Treated when you come to the school. Now the atomic number is nothing but what? Number of protons only. A nuclear charge is nothing but proton. Atomic number is proton. The nuclear charge here 3. Now what is the nuclear charge of what? The fluorine. I'm not taking the zero group elements. Leave it this one. Okay. The nuclear charge here 9. Now tell me, nuclear charge increasing or decreasing in any period if you observe? Any period if you observe,
Increasing, sir.
charge is always what happens? Increasing only. Now, when nuclear charge increases, what happens? When nuclear charge increases, what happens? Isn't it? So, compulsory what happens? The forces of attractions will increases, isn't it? So, for example, in lithium and neon. Neon, will leave it this one because neon I will explain later by taking some example. Okay. Now, if I observe what happened, the second period I am taking here. I have taken the second period elements. What are they? Lithium to fluorine. Take only fluorine. Now, the radius, what happened here? 152, 111, 88. 77, 70, 66, 64. It is not mobile number. What is this actually? Atomic radius in picometer. Now decreased or not? This is the data.
Yes, sir.
So based, if I say without data what happened, no need to what happened, believe. See, I have given the data here. What is the radius of the fluorine? 64. What is the radius of lithium? 150. It is decreasing. Leave it the neon. I will explain later why it is increasing suddenly. What happened? That we see. Okay, that may we see later actually. Now, in second period, you observe here what happened. The nuclear charge is what here? 3, 4, 5, 6, 7, 8, 9, increasing. That means 9 protons are attracting the electrons within the same shell. Here only 3 protons are attracting. The nuclear force of attractions here what? More or less in this case of lithium, tell me. In the case of lithium?
Less, sir.
Nuclear forces. जो attractions रहते हैं ना nucleus से, कहाँ पर रहते हैं attractions? On electron पे रहते हैं. Nucleus attracts always electron. Okay. So nuclear attractions here over the electrons. Which electrons, beta? Outermost shell electron. Because we are seeing that whatever the definitions, outermost shell only, that distance bit from the nucleus to outermost shell only we are saying. So the nuclear attractions of lithium will be low because it is having only 3 protons. Whereas in the fluorine, what happened? The nuclear force of attractions here, what happened? The nuclear forces of attractions in this case very high. Compared to that one, that will be high. Even though the electrons are increased here, you may say, sorry, here only 1 electron is there. No, there many number of electrons are there, but still that electrons are present. If you observe, whatever that electrons are present in the same shell only, no, and the second shell only, the distance is what same only, no, in this case. Here only electrons are, even though 1 electron, 2 electron, they are present on the same shell only, no. That is the reason. For example, 10 students are there. All the 10 students are sitting in first bench only. Okay. Now I can concentrate on the first bench equally, isn't it? On all the students here, because all they sit together in the first bench only. So no problem for me. I can attract all the students. I can concentrate on all the students here. Even though 1 student is there in the first bench or 3 students on first bench, I can concentrate more actually. I can see what you are doing actually. So if you sit in what? First bench. So if you sit, what happened? 3, 4, 5 students also, I can see I can observe what you are doing actually. Understood here? So what I mean to say is that atomic size, isn't it? Left to right is decreasing because the nuclear force of attractions or what happened? Increasing, isn't it? So we have written this one. The last, if you see this one. See? Across the period to the outer electrons are the same valency shell, because whatever the electrons are there, all the outer electrons are present in the same valency shell. And nuclear charge is increasing. See, from lithium 3 to what? 4 and 9 increasing. Now increases the attraction forces over the electron by the nucleus here. So because of this, what happened? Nuclear charge increases, atomic radius decreases. So अगर एग्जाम में आपको क्वेश्चन पूछता है ऐसा, what happens atomic radius in periodic table, give the reason. So what आप क्या लिखना है आपको? Atomic radius in period left to right decreases. Reason? Nuclear charge increases. Simply आपको लिखना है nuclear charge increases. That is the reason atomic radius will decrease in period. Now let me see now in the group now. Let me see in the group now. In the group, what happened? Atomic radius will increases here. Atomic radius now is increasing because the number of shells are increasing. The total number of shells are increasing, and the outermost shell is getting what? Away from the nucleus. Whatever the outermost shell is there, no, that is getting away from each other. To take this one, what happened? I have taken a group. Which group I have taken? One of the group I have taken here. Let me see that this is the group I have taken. If you observe what happened, the outermost shell for the lithium will be 2. For sodium, 3. For potassium, 4. For rubidium, 5. For cesium, 6. For the francium, generally we don't take because highly unstable. Its half-life period is only 21 minutes, so no need to take that. Now size increased or not? You see, as number of shells are increasing, size also increases here. Here also, you can say some doubt actually. What is the doubt of you? See, here also the nuclear charge is how much here? 3. Here the nuclear charge is what? 87. Now, here also nuclear charge is increased. No. In the previous case, in the period, nuclear charge increases, but outermost electrons are present in the same shell. But here, nuclear charge increasing, but the outermost shell, which is what actually what happened, moving from the nucleus here, moving away from the nucleus here. Otherwise, we'll take whatever the example we have taken for the period. What example I have taken? You are the students who are sitting in first bench only. In that case, I'm concentrating, I'm observing you easily. But these 10 students, if they sit in different benches, 1, 2, 3, 4, like that, one among in one bench like that. In that case, what happened? I cannot concentrate, I cannot observe the last student, because the last student will be away from the board actually. In that case, what happened? He can escape from the class easily, isn't it? So in that case, what happened? We cannot concentrate here. Similarly, what happened in the group also? What happened? Isn't it? The force of attractions from the nucleus over the valency shell electron. See, that is what. For example, valency shell electron will present here actually 2s. Now valency shell present here 6s. Now that distance what happened here increased or not? This is the distance increase. Yes. So आपको क्या देना है यहाँ पर? Because of increasing the number of shells, because of increasing the number of shells, what happened? Atomic size in the group what happened? Increasing top to bottom. So दो ये दो आपको याद रखना है इसका, दो proportionalities, isn't it? Atomic radius inversely proportional to the nuclear charge. When nuclear charge increases, atomic radius generally what happen? Decreases. If it increases, it will be decreases. And atomic radius directly proportional to number of shells. When you increase the number of shells, what happen? Atomic radius also what happen? Increases. These are the two things you need to remember compulsory, isn't it? Next, we'll move to what? Next slide. Some exceptions are there. What are the exceptions? Just now I told you, no, I'm not taking the noble gas. I'm not taking the noble gas. Just now I told you, no. Here you observe what happened. Just a minute. I'll show this one. This one you got suddenly 64 to 70 ho gaya yahan par. Well, it should decrease according to the rule. It should decrease, but 64 to 70, what happened here? Increased here. Neon. 64 to 70, what happened? Increased here. This you need to observe. Now, why this is? This is called exception here. Let me see that what exception you are having here. Now, see, this noble gases are having what type of radius? I told you just now. Which type of radius they are having? Just now I told you what type of radius it is having. Among
Vanderwaals.
Vanderwaals radius. Generally, when you compare with remaining covalent and ion, that means metallic radii, this Vanderwaals radii is what larger. That is the reason what happened. They are having some exception, isn't it? It is having some exception. It is having some more than that whatever the seventh group elements. So this is the reason you have to remember. Right? Next. This is some questions here. Tell me the answer for this atomic radius is
Inversely proportional to nuclear charge.
okay. Next, down the radius, tell me.
Increases.
Right.
Increases.
Now, this is about the atomic radius. Now I will take ionic radius. Next, I will take the ionic radius. We'll do one thing. We'll make this one short video.